Salaam alaikum. Can you hear my voice? Okay. Before starting today's lecture, I should mention again. I should repeat that because of the education announcement, we changed it. We had to change the time of the classes. So a group, both of the groups in a single group, and I changed the time of the class. On Saturdays, we use uh, links of the class of the first group, and on Tuesdays, we use the links of the group of the second group. Okay, and also I upload the first assignment. You can find the first assignment or homework number one in the LMS. You have 1 week time to complete it and upload the answers in the LMS. Homework right now, and let me know if you can see some problems in the assignment. Just check it right now. In the homework number one, I upload a file for you, a PDF file for you. In that PDF file, we have two questions, two separated questions, and you can see that via the description of the questions, and each of those questions have two sub questions. Okay, check it. Did you found it there? Okay, thank you, Naima. Okay. In the past session, we talked about wireless LANs, and now we want to talk about. Found it there? Okay, thank you, Naima. Okay. In the past session, we talked about wireless LANs, and now we want to talk about cellular networks and 4G and 5G technologies in cellular networks. In today's one of the basic technologies that we use to connect to internet is cell phone technology. This cell phone technology mobile connection solution. It means that I can use cell phone technologies, cellular network technology, to connect to remote base stations, remote from my site, maybe a few kilometers, a few 100 meters, or maybe a few kilometers. The distance between me and the base station is. So we call it a wide area mobile communication. And mobile means that I can move inside the cell, can go around inside the cell, and maybe sometimes I can leave one cell and enter to another cell. Okay, so we call it a mobile solution. That means that I can move freely. inside a network, inside a cell, or moving, departing one cell and arriving to another cell. The cellular technology today's is deployed widespread. It's deployed in most of the places and in the world. And if you look on, for example, Cisco statistics, Cisco has a special service for uh, prediction on in 2019, number of mobile broadband connected devices against number of fixed broadband connected devices was 5 to 1. It means that if I have one fixed broadband connected device, at the same time I have 5 different mobile broadband connected devices. That is great. It means that most of today's internet users, most of them are services rather than using fixed connections. Okay. For example, in Korea, South Korea, 97% of people are using 4G, can use 4G connections. In the USA, 90% of the country is covered by the 4G technology, and now we can see that the Chinese scientists deployed 5G technology in their country and in several other countries. In Iran, we have some 5G networks too. Okay, in 4G technology, the transmission rate is up to 100 megabit per second, and in 4G we are using standard techniques deployed in third generation technologies, in third generation solution of the cellular networks, third generation partnership project 3GPP, and LTE. In 4G we can see the LTE standard, or line term evaluation standard, is dominant over the cellular networks all around the world. Okay, let me try to compare cellular technologies with fixed or wired broadband technologies. If we try to talk about the similarity between the wired and wireless technologies here, is that although we can say that we can see that at the edge we are using wired or wireless technology, at the core of network, both of them, both wireless or wired technology, use similar carrier. Okay, and also we can see that the global cellular network is a part of today's internet. It consists of some network of networks, and in 4G and 5G technology we can see that the scientists use several IP protocols in the back end of those cellular networks. They are using IP technology, IP, HTTPS, DNS, TCP, UDP, IP, NAT, and several other protocols, Ethernet, tunneling, SDN. Okay, both of them in 4G, 5G cellular networks and or in wired network. The backbone of those networks is IP. And both of those wired or wireless technology are connected to the internet via a wired backbone. Both of them. Okay. But what is the difference between them, between a wired network and a wireless cellular network? The first and main difference is using the wireless link layer. Here in cellular network, we are using a wireless connection, but in a wired network, we are using a wire between, for example, my home and the ISP. Okay. The second difference between these two connections is that here in cellular network, the users can be mobile. In other words, I can say the mobility is the number one, the first class service of a cellular network. That is great. Just I use a SIM card, nothing else. A cell phone and a SIM card. Then I can move across my country, okay? Across the world. I can, for example, travel to Iraq and use my cell phone in Iraq just by using my SIM card. Or moving toward, for example, going to Canada and the other side of the world. And again, I can use my SIM card over there. Just I need to use that SIM card. That SIM card makes clear that who am I. Okay. So my identity is my SIM card. I can be known in the network using that SIM card. In a wired network, I should, for example, I'm using an ADSL connection. In ADSL technology, I should announce my static, my I should connect to ISP using my public telephone, my wired telephone, okay, telephone number. I should announce the my phone number, my public phone number, my wired phone number to them, and they can they make a connection toward my home over that phone number. But here, just I'm using a SIM card. Okay. The first difference between them is that here business model is completely different from those business model in a wired network. Why? Because basically when we develop a cellular network, in a cellular network we try to support and to make a wireless connection and support phone calls basically, and after that in 3G technology, after that in 3G technology, 2G and 4G, and after that in 5G, the telecommunication companies try to adopt their technologies with data world. And at the same time, we should mention that In a cellular network, my user is a mobile user. It means that he can travel across the network over the country. Travel. When I'm using a wired technology, for example, using an ADSL technology, ADSL line connected to my home, I cannot move across the. I cannot move even to the other side of the street. I can use my ADSL inside my home, but in cellular network, I can move across the country. For example, I can move from Iraq to Tehran, to Mashhad, to Bandar Abbas, to Tabriz. Okay, I can move to Baghdad, and again, at the same time, I can connect to the network. So I have a home network, a visitor network, and I can change my room from my home network to the visitor network. Okay, so I have global access. I need an authentication infrastructure. How they can, how the telecommunication company can define that I am using, for example, the internet service over the network. They should authenticate me firstly. Again, I'm moving across the country. So, for example, if I'm in Iraq, I'm traveling to Mashhad. So, at the same time, the telecommunication company should know or should authenticate me. Okay, Hossein is in Mashhad. So, they authenticate me and then they will send a bill for me at the end of the month. Okay, you travel to Mashhad, you use your SIM card. In Mashhad, you use your data connection in Mashhad, so you should pay. How? They authenticate me in Mashhad. So my telecommunication company needs an authentication infrastructure to do this. And sometimes, for example, if I travel to Karbala, to Najaf, to Samarra, to Kazame, okay, at that time I'm moving to Iraq, and in Iraq I'm using a service from another company. It means that that company who serve me in Iraq should make an inter-carrier settlement. Make an agreement. Firstly, it should make an agreement with Iranian telecommunication companies, and then I can use my cell phone in Iraq. And then my connection, I have an inter-carrier connection. The telecommunication company in Iraq should forward my connection to Iranian telecommunication company, and then they should authenticate me. They should forward my call toward the destination. So the technology used in cellular networks, in wireless cellular networks, is completely different from those technology have been used in wired environments, wired internet. Okay? So in 4G technology, when we say that, okay, I'm using an LTE technology, we have some elements. The first and the main element is my mobile device, a smartphone, a tablet, a laptop, or any other devices. Okay, any other devices that I can connect from that device, connecting to a 4G or an LTE uh, infrastructure. When we talk about the cell phone and using cell phone technology over, for example, on a smartphone, we need a SIM card. SIM is an abbreviation for subscriber identity module. In 4G technology, this module has some changes when we compared it with 2G or 3G technology. But at the same time, we have a 64-bit international mobile subscriber identity, or IMSI. When I'm connecting to internet, the IMSI of my cell phone should be registered in the telecommunication company. So that for the no. Just I made an interrupt in my voice. Excuse me for that. Okay, so I'm using two identification in my cell phone. The first one is IMSI, which is something MAC address. IMSI is placed in my cell phone, and when I'm connecting to a mobile cell phone network, the network can identify my cell phone device using that IMSI. Each of those places for SIM cards. For example, you have a cell phone with two places for SIM card. Okay, each of those places has a different IMSI identity. It's a 64-bit identity, and it's an international identity. Okay, and this we use this ID to make it clear which I'm using which device. This ID is unique. Okay. The second identity that I'm using in my cellular network is my SIM card. And we know that the SIM card is something related and dependent to my telecommunication company. If I want to use a service from a specific company, I should buy the SIM card of that company, SIM card from that company. Then I can use it. Okay. Uh, uh, so we have a user equipment, or maybe someone said LT jargon. This is the user equipment. I'm connecting to the LTE network using that mobile device. Okay. Look at this figure here. Let me zoom this one here. Here we have some cells, and at the heart of those cells we can see again a BTS. The mobile devices are connected to that BTS. Okay. In LTE we say base station or E-node-B in LTE. In cellular network, as we talked about it in the last sessions, in cellular network, in wireless network, we call this tower, we call it a base station. In LTE technology, we call it E-node-B. We call the mobile device as UE. In LTE. These terms are something in LTE technology. Please be care about this. In LTE, we call UE. We call mobile devices as UE. The base station is E-node-B. And you can see that some of those cells are connected to a bigger cloud, a bigger network here. Some cells, okay, a few cells are connected to a bigger network. Here, when we talked about those cells only prepare a radio access for me. So we call them radio access network. It means that here I'm using a two-level hierarchy network in LTE architecture. The first level is radio access network. In this level, just using some E-node-B, we try to connect different devices to a cellular network, and then in EPC is enhanced packet core. And now in 4G technology, this core is fully IP core. If I go back to our story, the first generation of the cell phone was an analog network. The second generation was a digital version of our telecommunication company. In first and second generations, we use circuit switching technology, same as the other telecommunication networks. Okay, in first and second generation, the first one was an analog network. The second one was a digital network, digital circuit switching network. Okay? But in the third generation, for the first time, we can see there are some IP backbones in cellular networks, but some parts of networks use IP technology. Just some parts. Okay? But in 4G, we can see that the backbone of network is fully IP-based technology. So we said all IP enhanced packet core, or all IP EPC. So this backbone is EPC, enhanced packet core. And you can see that at this time, during the history, at this time, we should forget circuit switching technology in most of cases, especially in phone networks. Okay, in EPC, you can see that we have a backbone of some connected devices, some connected routers. Okay, service gateway routers, PDG gateway routers, a link toward the internet if I want to use a data service, so I should connect to internet. So we can see there is a PDN gateway or PGW gateway, a gateway toward the internet, and at the same time you can see two other main servers. Please remember these servers. One of them is Home Subscriber Service, or HSS. Remember this service, this server, Home Subscriber Service. Why we should remember this? Look at this database. The database connected to HSS server. What's that database? What is the role of this service, this server here? When I'm buying a SIM card, a new SIM card, I should prepare some information about my identity. And the company will register those identity information of mine. Okay? Those information should register in this database. The database connected to Home Subscriber Service, or HSS. So the company can know who am I. Always they know who am I, because my identity information has been saved in this database. And when I'm trying to call someone else, my call will forward to this service, to HSS server. Okay, and at that time, at that place in HSS server, I will be authenticated. Who am I? Oh, yes, Hussein. So he can use, for example, a phone call service. But he cannot use an internet service. His service is finished, or his account is blocked. So block his phone call. Okay. Here in HSS service, the company can decide about my request. A request for making a phone call, or a request for using internet. Here in HSS service, we can think about this and making a decision about each of those requests from the users. And we have another main service too, Mobility Management Entity, or MME. What is this? MME server is used to handle my mobility behavior. I say that I can move across the country, even across the world. So who am I? For example, in Iraq, who am I? The company in Iraq will look for my cell phone. Okay, this cell phone number is for Iran, for example. So I should forward it if there is an agreement. If there is an agreement between an Arabic telecommunication company and an Iranian telecommunication company, then that Iraqi company will forward my call and my information toward the Iranian company. And they ask, okay, who is he? He's trying to make a connection. Do you know him? And then the Iranian company will look for my in the in my HSS. In the HSS, they look for my cell phone, for my information, and say, okay, I know who is Hussein, for example. Okay, so just service it. We will pay for his connection next time. Okay, maybe say, okay, I don't know who is Hussein. I'm sorry, I don't know who is him. So just block him. I don't know who is. So the base station is the edge of the carrier network. The base station manages the wireless resources, mobility devices, uh, those connected to the base station in this cell, coordinating uh, device authentication over the element. This base station is something similar to Wi-Fi access point. However, the Wi-Fi access point, uh, the role of a mobile user is limited in, in Wi-Fi networks, but here in cell phones, cellular technologies, we can see the user mobility is very important. So we should actively handle mobilities in wireless networks. And as I see, we called it in LT. We called the base station as eNode B. Home subscriber service. We talked about this one, and also we talked about the gateway toward the internet or serving gateway and PDN gateways. Talked about them, and we said that okay, if you want to make a phone call, you should use those gateways connecting toward another server or making it and using a tunnel, something like that. Okay. And in mobility management entity, as I said, when I'm moving from one network to another network, if I'm still in networks of a single company, so that single company, for example, my company, for example, I'm using MCI. MCI SIM card and an Iran SIM card. Okay, I have two SIM cards. So when I'm moving, for example, from Iraq to Mashhad, uh, still I'm under the coverage of MCI network. So in this case, I can use the HS services. But sometimes I'm moving between the cells, or maybe I'm moving uh, from network of one company to a network of another company. So here we have to manage the mobile device because that mobile device handovers from one cell to another cell. So we should track that mobile device and when there is a call, we should page for device location to find it, and finally we should create a path, a tunnel between um, the caller and me. Okay, creating this path is a part of task that should be done by PGW. Okay, over PGW, we try to set up that tunnel or path uh, between the caller and me. When I'm a mobile device, I'm leaving the home network. Okay, look at this here in this slide. In this slide, you can see that I'm connecting to a base station, for example, using a cell phone, and this connection is uh, moved moves toward enemy, and then you can see there is a connection between enemy and HSS service. We can move the connection toward GW. Here, we can look for this device, for this connection. We can look it as a control operation, or we can look at it as a data operation. What does it mean? In control plan, we just control everything. For example, when I said that when I'm trying to make a phone call, firstly, my company should check my balance. For example, okay, his balance is over. He cannot make a connection. This is something happens in control plan. My connection is redirected toward MME and then HSS service. And in HSS service, they said that, okay, this call should be blocked. This happened in control plan. But in data plan, we are looking for a path to our destination to send information. We should create a tunnel between source and destination. And at that time, creating that, please note that creating that tunnel between the source and destination over the backbone of LTE is not easy. Why? Because my user is a mobile user. He can move, he can go from one cells into another one. So we have to create a tunnel while we are aware about the mobility of so when we talk about counting only in the router, no. Please look at please be aware, be careful, Naima. Nothing happens in these gateways. All of the control process have been done in MME and HSS servers. Those servers control everything. And after that, they send information to SGW or PGW to S or P gateways. Okay. Here, those servers should decide about the actions that we should do against a packet. Okay, look at this slide 45. This something interesting happens, has been shown in this slide. This is my cell phone in the left side, which is connected to a base station or node B. Okay, look at the stack protocol of these two devices, my cell phone and an node B. In my cell phone, I can see the application transport IP. I can see top three layers of TCP/IP protocol, and there are some other layers at the bottom of this stack. We can see some other layers, and at the same time, we can see similar layers in base station. Look at this one here in my cell phone. Under the IP layer, you can see the link layer and physical layer. A link layer with 3 sublayers and physical layer. Again, in base station, we can see similar layers and sublayers. And an IP layer here. You can compare this protocol stack with a protocol stack in a router, for example. Please look on chapter 1 slides. At the end of chapter 1, there is a figure about the layers, different layers in different network devices. For example, in a switch, in a router, you can look for that slide and compare it with this one. So here, we can say that the base station is something similar to a router. But when we talk about a router, this router works over a wired network. But this base station is placed under the edge of a network, an edge between a wired word and a wireless word. So you can see here that when the BTS is connected to wireless side, it has to use a wireless MAC for wireless technology, for LTE technology. And MAC of LTE technology has 3 different sublayers. The upper one is packet data convergence. This sublayer is responsible for encapsulating the IP packets into a frame that should be sent over the wireless one. Creating that frame is not easy. Please pay attention to this. Creating that packet, data frame is not easy. Why? It's not an easy operation because we have to information different we should look for different aspects in this area. Why? Because it's a wireless link. Because the middle sublayer is a radio link. We have a very specific sublayer just for why this sublayer is important. The answer is that because we are trying to prepare a wireless network over the buildings and obstacles in a city, obstacles with different uh, shapes, with different sizes. So sending information over this link, over a wireless link inside a city with different obstacles, different buildings, tall buildings, towers, trees, different size, different vehicles, bicycles, bikes, people, types of obstacles in a city. And we have to prepare a wireless connection over that complex system. A city is a complex system. It's not easy at all. So we have a very specific and expert scientist to create that radio links between me and the base station. This is one of the main differences between different uh, generations of cell phones. How I should create and manage those radio links. I should control it. For example, when I'm talking about a 3G network and a 4G network, the main difference is in radio link. And even when I'm talking about a 5G technology, the lower sublayer is medium access is something like to medium access control or MAC layer. Uh, this sublayer is responsible for transmitting information between the cell phone, for example, and the base station. Okay, medium access control. How my cell phone can access to the medium, uh, to medium for connecting, for sending or receiving information from the base station. Okay. But maybe someone says that, okay, in Wi-Fi we have the channel. Okay, that's true. But in Wi-Fi, if you remember, I said that, okay, in Wi-Fi, if you send information, you cannot receive information at the same time. I'm sending information and I cannot receive information at the same time. But my experience in a cell phone, in a cellular network, has something else. When I'm talking over my cell phone, at the same time I can hear the voice of other side. The voice comes from other side. So what is the difference between a wireless link in Wi-Fi and the cell phone? In cell phone technologies, always we have, when I'm connecting to a cell phone network and I'm trying to, for example, make a phone call. Okay, I'm trying to call someone, for example, my friend. When I'm trying to access to the network to make a phone call to my colleague, to my parents, to my friends, the network will assign two different channels to me, upstream and the other for downstream. What does it mean? It means that I have two channels. So at the same time, I can send information over the upstream channel. My voice can be sent over the upstream channel, and at the same time, I can receive information or the sound of other side from the downlink channel or downstream channel. When we maybe someone you see that okay, we are a TDLT, a 4G TDLT technology or network or FDM technology or OFDM or something like that. Maybe someone those terms refers to the structure of how that company is shared the air resources, the channel resources between different users. We talked about FDM and TDM in the last uh, lectures, so I'm omitted to talk about them again. But maybe you say that, okay, what is OFDM? OFDM or orthogonal frequency division multiplexing is a technology that in this technology I'm using orthogonal channels. What is an orthogonal channels? Um, do you remember CDMA technology? We talked about it in the last week, I think. And I said that, okay, when I'm using CDMA technology, I can assign a code, a unique code to each user, and the user, when the user tries to send information to over the network, it should times his information with that code, that unique code, and then send over the network. And we said that that code is something interesting. Why? Because those codes are orthogonal comparing to them. And I compared them to them, which are to each other. Those codes are orthogonal. And here we can use a similar technology, an orthogonal technology to send information without any interference. And for upstream use, we can use FDM or TDM technologies. Uh, trying to make a phone call over a 4G technology, my mobile device, the base station, can assign some frequency bands. They will assign some frequency band for me. But that is interesting. Those frequency or time slots are not scheduled. There is no standard scheduling techniques to assign the bandwidth between those different frequencies. But we can say if I use LTE technology up to 100 megabit per second can be received to each of the devices in the network inside the cell. Okay, and here you can see the other side of the cellular technology. We talked about this part, the wireless access network, and now in wireless access network. After that, I should send information toward the core to make a decision. And now you can see that when we are going toward a wired network, the protocol stack of the devices inside the wired network is something else. To pull out this information, I can make a tunnel, make a tunnel toward the destination. For example, encapsulating datagram into GPRS tunneling protocol, and then sending datagrams toward the S gateway or P gateway. Uh, we can use this tunneling technology. However, when I'm using tunneling technology, it's something hard to change the endpoints of the tunnel. After setting the tunnel, I cannot change the destination easily. Okay. How user is connected to an LTE network? When a user tries to connect to a wireless network, we call it association. So the question is this: how can I associate with with a 4G base station? It has 4 steps. First step is that uh, the base station broadcasts some signals every 5 milliseconds over the whole frequencies. Okay. These broadcast messages are something like to beacon frames in Wi-Fi. Okay. My cell phone, my mobile phone, search for that uh, broadcast signals comes from base station. Search for them and find it tries to find some empty signals over the frequency range of that network. So in the second step, the mobile phone should look for the broadcast message comes from the base station and find the bandwidth, channel bandwidth, configuration, and something like that. Information, totally information. Some information comes from the um base station. After that, my cell phone should look for those should look within those information to find the best solution. After defining uh, right information, then my mobile phone can try to associate it with the BS. And maybe sometimes after this, maybe with some more other operations, for example, for authentication, for establishing the states or setting the data plan or something like that. Okay, maybe we need some other um, we need to do some other operations here. Um, One of the main specification of the LT is the sleep mode of uh, we talked about sleep mode in Wi-Fi when we talked about Wi-Fi or Bluetooth in the past lectures, and we said that because my device uses a battery to these jobs, these tasks, so I should care about the level of that battery. And as I said, in Bluetooth and Wi-Fi, save the battery, we need to use um, more to come. We have two different types of sleep in cell phones. One is light sleep. In this type, my device should be off or should be inactive for 100 milliseconds. After that, it will wake up and search for the information. So uh, my device can sleep for 100 milliseconds. The second sleep strategy is deep sleep. In deep sleep, instead of um, in deep sleep, my device will go to sleep for 5 to 10 seconds. That is 5 to 10 seconds. My device is off, so it can save its power. But when we talk about a deep sleep, okay, so we can use sleep modes to save the battery of the cell phone. As we talked in the past slide, the backbone of today's uh, cellular technology is fully IP. So I can say that everything, my mobile home carrier network, my everything here in this cloud, you can see that uh, every places, every networks are on the IP base, and If I want to send information from one site moving across these three, I can use them. So in RP 4, we use a completely IP-based networks. My backbone is fully IP-based. It means that if I want to handle my packets, instead of 1G, 2G, 3G, my phone call or my uh, data connection should be handled completely in a different place. But here, in 4G, everything is on IP. Everything. And we talked about the benefits of IP and datagram networks in the past in chapter 1. Okay, this is the last slide of today's lecture. Uh, in these days, we are moving to 5G technology. But what is the difference between a 5G technology and a 4G? The primary goal is this: increasing in peak bit rate over 10 times. Okay, so we are looking for bit rate 10 times more than 4G. We want to look for a network with 10 times uh, less latency, less than version 4, and 100 times increase in traffic capacity. So in 5G, I'm looking for a very high bandwidth wireless network. Reaching these capabilities, these goals, is not easy. So to do this, we can see the scientists assign new radio channels for 5G networks, or we call it 5G NR. NR means new radio. Everything, the uplink and downlink, with new frequency channels without backward competitors, and we need to use the advanced technology in antenna design, for example, using MIMO or something like that. Okay, but when we talked about 5G, there is one important note. If you look on the internet, you can see that in 5G networks, we are using uh, in 5G, we are using gigahertz frequency bandwidth signals. This means that those signals have a higher frequencies. they can send higher amount of data. But because of their um, high frequency, those frequency has those frequencies have a large amount of energy. So they are not useful for the nature, for body lives. It's very important. That frequency ranges has lots of power and they are not good for our lives. And also, those higher frequency makes a shorter communication range. So in contrast with 4G, 3G, 4G, 2G technologies, in 5G, we have to use picocells. It means that those cells has only maybe 10 to 100 meters radius. Oh, excuse me, diameter. The diameter of those cells is less than 100 meters. What does it mean? It means that I need to deploy too many base stations in a city. If I'm looking to install 5G, for example, deploying 5G my city, I have to deploy too many towers, too many base stations in the city. Because here, I said that in 5G we are using picocells. Okay, we have too many cells, too many picocells, small cells. So we need too many infrastructure, a dense deployment, massive deployment, which is costly. So we have to pay too many money. We have to pay a lot, big cost. We have to pay for big costs, over big cost, and at the same time, still we have some concerns. We're worried about the harms of 5G technology because the 5G technology uses microwave frequencies, with higher, with very high signals with very high frequencies. For example, maybe some people talked about 60 gigahertz signals. It's very dangerous. Yes, Naima, especially in 5G. So when we look over the trend of new emerging technologies over the world, you can see before 5G, you can see that always the USA has the flag. The USA is the leader in developing new technologies. Okay, always until 4G, but in 5G, the USA never talks about the implementation of 5G technologies. You can see that in the West, nobody looks for those technologies. There's no company who said, okay, I want to deploy this technology. But in the West, the Chinese company always talk about 5G. For example, Huawei said, okay, let me install 5G networks in your country. But if you look closer to this technology, first we should answer that how they resolve those harms, especially for cancers, for uh, bad effects on bodies, on people, on animals, on trees. It's very important. Firstly, I think firstly we should talk about these harmful aspects of 5G technology, and then going toward those technologies, such as 5G technologies. And now, in current days, if you search over the internet, you can see some people are looking for sixth generation of cellular networks. That is important. That is interesting. Still, we are standing in the first steps of 5G technology, but some people are looking for sixth generation of that technology. And the last thing in this lecture, if you look over the structure of 4G, 5G, and 6G, you can see the artificial intelligence technology, AI, has been used vastly in 5G and 6G, the fifth and sixth generation of cell phones. They are widely used in those networks. Why? Because, for example, in 5G, I said that, okay, I'm using picocells because I want to use signals with very high frequency uh, signals. So they have two power. Those signals have two powers, and they are at the same time their communication ranges are very short. So I'm using picocells, and the main question is this: how can I control those picocells? How can I control those picocells, especially in mobility aspects? Okay. Inshallah, in the next lectures, we will talk about mobility and we show that how we can control a user in a mobile cell phone, for example, a cell phone or in a mobile IP environment. It's very important how we can handle those mobilities in wireless networks. Okay. Uh, Thank you for joining the class. Is there any question? Any question? Okay. Have a good time. Goodbye.